Hi, in this video I will talk about another common way of storing sequential data, and it's named linked list. Let's start with an example again and say that you are on a holiday visiting different European cities like London, Paris, Rome, Berlin and so on. While you are in a specific city, you want to know how you got there and what comes next. So you keep links to these two destinations and reset them each time you visit a new place. This is the basic principle of a linked list. There are different types of linked lists, but in this video I focused on the doubly linked list, meaning that each node stores a reference to the previous and next nodes. The basic unit of the list is a node, and it will implement the position interface. The one required method defined in the interface is getElement that will pass the value stored in the object. The node itself is a class that will hold three properties and a collection of getters and setters for these. The properties are element to store the desired value, previous node a pointer to the previous element, and next node a pointer to the next one. The collection of methods consists of the following: getElement to retrieve the value of the node, getPrevious for returning the node before the current node, getNext for taking the node that follows the current one, setElement to update the current value, setPrevious and setNext to update which nodes the current element is pointing to. In the list interface, we will define the methods our list must have. These are size, isEmpty, first, last, before, after, add first, add last, add before, add after, set, remove and iterator. During the list initialization, we will create two sentinel nodes: header that is completely empty and trailer that points to the header. Then we update the header's next reference to be trailer and initialize the size property that is set to 0 at start. We would like to access the list elements but isolate the header and trailer, so we will build a method that will check if the requested node is one of those two. If the condition is true, then nothing is returned, otherwise we pass the node. Now, any method that will access list nodes will go through these. Some examples of such methods are first, last, before and after. The first method will access the first node in the list through header's getNext method. Because the fresh list does not have any elements, this method will return none, caused by the isolation method created before. The same thing applies for the last method, but this time we use the trailer's getPrevious method to access the node. But if the list is already populated, the header and trailer will point towards some nodes. The before method will take a node argument and return that node's previous element. The after method is similar, but will pass the next element of the node. Let's roll over a bit and look at how we insert elements in the list. The add between method will take three arguments: element as the value to insert, predecessor the element after which to put the node, and successor, the element before we want to put the new node. Firstly, we create a new node instance with those values, then update the predecessor's reference to the next node to be the new node. After that, do the same with the successor and previous node reference, and finally increase list size and return the new node. The add first method will have only one argument, the element, because the nodes passed to the add between method will be header, and headers gets next node. The add last will have a similar structure, but the arguments will be the previous element of the trailer and the trailer itself. Another method to insert element is add before, that will take a node and value, and call the add between with the same value, the previous node of the node argument, and the node itself. The add after is built similarly, but will call the add between with arguments node and node getNext. The remove method will take one argument and it will be the node to delete. Inside the method, we get the node's predecessor and successor and update those nodes to point at each other. Then we decrease the list size by 1, store the current value in a variable, set the value, previous and next references to none, and return the current value. The remove last method will take no arguments and will call the simple remove method with the trailer's previous element as the argument. And the remove first will call it with the header's next element as the argument. Let's get back a little and look at how to update an element. The set method takes two arguments, node and element. It retrieves the current node value in a variable, calls the set element on the node with the element argument, and returns the old value. The size method will just return the size property. And the isEmpty method will tell us whether the size is equal to 0 or not. ToString method will walk along all elements as long as it does not reach the trailer node and append their values to a string that will be returned in the end. Finally, the iterator method will instantiate a new linked list iterator class and pass itself as the argument. The list iterator will implement the iterator interface that requires two methods, hasNext and next. At the object creation, we will store three properties: the linked list, the cursor that will indicate if there is a next element which will be initialized as the list's first element, and the recent property that will store the element to return in the next method if that element exists. The hasNext method will compare the cursor with an empty value and return the result of this comparison. The next method will assign the value of the cursor to the recent property, then update the cursor with the next value of itself, and return the recently visited value. Now let's test our code. We will create a new doubly linked list, then insert 5 values at the end using addLast method and 5 values at the start using addFirst method. Then we will get the first and second nodes using first and after methods and show them in the output together with the entire list. You can see the output on the right. Then we will remove the first and last element, add a new element at the start and output the entire list again. Last thing to be tested is the iterator. We initialize the iterator and then using a while statement output the elements as long as they exist in the list. That's it for this video. See you in the next one.